So here's question 1 from 5.1, the amount of an annuity. So that Paul deposits $1,000 at the end of each year in an account that pays 5% compounded annually. What is the amount in the account after 10 years? So the first thing I do is I get my interest rate. So I go I equals 5%, so 5%, and I divide it by 100. So my I equals 0.05. Now, since it's annually, I'm going to multiply by the number in the table, but this one's annually, so I don't have to do it. But just to stay consistent, I'm going to bring this table over here. Okay, and in the table it says annually. There's no change, so the interest rate gets divided by 1, and the number of payments gets multiplied by 1. But I'm going to show it just to stay consistent, so I do it for all of them. So it's times 1, so my interest rate is 0.05. N. Okay, N is 10 years. And you would also multiply by 1 or whatever number. Sorry, this one would be divided by 1. I made a mistake. And this one would be multiplied by 1. So it's 10. So you take your interest rate and you divide it by 1. Or you divide it by the number in the table. And then you take your N and you multiply by 1. We still need one more letter. And that's your R for your formula. So R here is $1,000. It's our regular payment. Then I go and write my equation. So I write A equals R, and it's in the note. So if you don't know where it is, it's in the note right on the top here. It's A equals there, right from the note. Okay, so I'm just writing that equation. A equals R, bracket, 1 plus I, as a decimal, to the power of N, all over I. And I sub in the value. So R is 1,000. 1 plus I, so 1 plus 0.05 to the power of N. So that's to the power of 10 minus 1 all over I. So all over 0.05. Now at this point, I get my calculator out. And what I see there, that whole equation I see, I type it into my calculator. So let the calculator do all the work. So 1,000, okay, bracket, and I put double brackets as a square and a round bracket. 1 plus 0.05, sorry, 0, let's type that in correctly, 0.05, just like it says on the screen, close the bracket. Now I put the exponent, so I need the exponent button. So hopefully you can find it. Mine's a little hat to the power of 10. Then I go subtract 1. I close the bracket. So now I've got the double brackets. I've closed them. And I divide by 0.05. So all this gets typed in. So I don't know if you can see that clearly. I'll bring it up a little higher. So I put 1,000. And then I got my double brackets here. Bracket, bracket, 1 plus 0.05, close the bracket, to the power of 10 minus 1, close the bracket, then divide by, and you could put 0.05 or just 0.05. And I hit equals. And it tells me my amount, 12,000, and you're out to 2 decimal places because it's money, $12,577.89. So in here, I put $12,577.89, and I put a therefore statement. Therefore, the amount is 12,577.89. Okay, we'll go back to full screen. We're going to move on to the second question. So we're going to go to question 2. We'll bring the sheet down here. It's going to focus in here with my camera and run question 2. We're going to follow the exact same process as question 1. So here it says Anika deposited $800 in an account at the end of a 6-month period for 7 years. And it was semi-annual. The account paid 9% semi-annually. Determine the amount in the account on the date of deposit. She got pretty lucky. 9%. Pretty high, and even that 5% on the last question was high. And we will go I equals, so I equals, well, we got 9% divided by 100. So our first step is to turn that into a decimal. After that, it's semi-annual. So you go to that table or that chart and you want to figure out. So I'll bring the chart up over here that I have. Okay, you go semi-annual. So you follow the line semi-annual. Oh, you divide the interest by 2 and you multiply n by 2. So you get it right from the chart. So divide the interest by 2. And here are n. So let's see how many years it is. So n, 7 years. So you take the 7 and you multiply it by 2. So this one you multiply by 2 is 14. This divide by 2, you can use your calculator, 0.45. One more number, we need R. Let's see what our payment is, 800. Now we write the equation. So we go to our sheet where our equation is. So we get our equation from our sheet over here, this handout. So you need this note. And you get A equals R bracket 1 plus I to the n minus 1, close the bracket, all over I. Fill in the necessary information, 800, 1 plus 0.045 to the power of 14, minus 1, close the square bracket, all over I, 0.045. Perfect so far. Now we get our calculator. We type what we see in this calculator. So exactly, we'll bring that right up to the top, and hopefully you guys can see. Hopefully my light's not reflecting too much. I'll put it right here. We'll clear that. So we put 800, bracket, and a bracket, 0.1 plus 0.045, close the bracket, to the exponent. So I got a nice little hat for exponent button. 14 minus 1, close the bracket, and I divide it by 0.045. And I hit equals. And I get 15. So I'm just going to write off the calculator, 15145.69. So I just round it to the 2 decimal places, and I put therefore the amount is 15145.69. And I write it there. Now question 3. Jill wants to buy $1,000. So Jill wants $1,000 to buy a ring when she graduates high school. She deposits $40 at the end of each month in an account that pays 6.5 compounded monthly. Jill will graduate in 2.5 years. Will she have enough money by then? Okay, let's find out. So that's pretty good. 6.5, that's pretty high, but let's convert I equals 6.5 divided by 100, 0.065. Then it's monthly, so you divide it by 12. Okay, how did I know 12? I go to the table here that I had, right here, and monthly, 12 and 12. That's where that comes from. And I'm going to times n by 12 and divide the interest by 12. So over here, n is 2.5 years, so 2.5. So hopefully you know that a half is 0.5. So 2.5 times 12. So that's our payments. So we'll go to our calculator. We'll figure this out here. 0.065 divided by 12. Okay, now how many decimals do you have? Because look, I put it divided by 12. The more decimals you keep, the more accurate you are. So the more of these you keep, the more accurate you are. I'm going to put like 4 numbers down. I'm going to put 0.0054117. So the more of these you have, the more accurate. 0.54167. I'll even have even more. And so times 12, so 2.5 times 12, 30. That turns out to be a nice number. And our payments are $40. Okay, let's see if she has enough money. Let's put it into that equation. A equals R, bracket, 1 plus I to the power of n minus 1. We put it all over I. So our regular payment is 40, and bracket 1 plus 0.0054167 to the power of 30 minus 1 all over 0.005467. Let's get my calculator out. Hopefully you can see the numbers there. Maybe I'll put it right underneath. I'll drag this up too far, and so you can see me type it all in. I'll clear that. Now if you have a two-line calculator, you just type and you can see what you're typing, the double bracket here. 1 plus 0.005417, close the bracket, exponent 30, minus 1, close the bracket, divided by 0.005417. So if you can type it on a two-line calculator, you still put the double brackets exactly what you see. You type, you might have a different exponent button, and you hit equals. $12.99 and 19 cents. $12.99 and 19 cents. So $12.99 and 19 cents. She will have enough. Okay, she'll even have $299.19 extra. Look, she wants $1,000, so she's going to have a little bit more. So therefore, Jill has more than enough. Okay, she has actually $299.19 more than she needs. And we'll just write that out. So we got an extra $299.19 on top.